Okay, question 7. One number plus the square of another, total 27. Find the number so that their product is a maximum. Okay, well, you might recognize this question from Math 20, something very similar to it. So what we've got here is there's two numbers here, okay? So we've got x and y here. And we know that one number plus the square of another is 27. Okay, and from here, right here, I can see that, what I would do with this is I'm going to let x equal, for example, 27 minus y squared. That's just, I know that at some point I'm going to have to solve for a variable, and that's just the easiest way to do this. Okay, now the question says I want to find it so that the product is a maximum. Well, okay, so I need to have their product, x times y, and I already know, because I knew this was coming, that I'd have to substitute in an expression for x here. So it's going to be 27 minus y squared times y, and when I expand that out I get 27y minus y cubed. Okay, so here's the function that I want to maximize. To maximize it, I'm going to take the derivative. Okay, now I'm also going to change the order of these things because I like to have the cubic first, so I'm going to make that in my derivative negative 3y squared plus 27. And to determine what the maximum is, I'll set that equal to 0. Factor out the negative 3 because I don't want it in there, but that leaves me with y minus 9 in there, which is awesome because that is a difference of squares, which means in my final answer y is either going to be plus or minus 3. Okay, now when I look at my derivative, I notice that it's a quadratic that opens down. So it's a quadratic that opens down. It's going to look like this. And based on its own roots, I know that this is going to be at negative 3 and positive 3. So this is telling me how the original function is behaving. To the left of negative 3, the derivative is negative here, which means the original function is decreasing. On the right, it's positive, so it's increasing. And then over here, again, when we drop below, when the derivative drops below the x-axis, I know this means the function's decreasing. Why is that significant? Well, because the question said find the number so that their product is a maximum. Well, the maximum is going to occur right here, where it's increasing on the left and then decreasing on the right. Okay, so it goes up and then down here. So that happens when y is equal to, actually I'll write it out like this, when y is equal to 3, and then if I go back up to this question up here, to get x, I just plug that in, and I'll find that x is equal to 18. So the point that we're trying to get here is the point 18 comma 3. That is, those pairs of numbers satisfy the requirements of the initial question.